constructive interference, bright fringe. It is n lambda. It is alternate bright and dark bands. Reaching the point P is x into d divided by capital D. Therefore, the central point is always bright. The two superposing light waves should be nearly equal. Hello students, let us continue our discussion on interference of light. In my yesterday's class, we studied the theory of interference, and through that we observed and analyzed the conditions for constructive and destructive interference, both in terms of path difference and phase difference. But today's class is a very, very important session where I understand a 5-mark derivation often asked in the exam, the width of interference fringes, the so-called fringe width. Therefore, in today's derivation, I will obtain an expression for fringe width obtained from Young's double slit experiment. Before we creep on to the mathematical part, we will try to understand what actually is fringe width. What is the meaning of fringe width? Now, so this is what we try to understand fringe width, which is denoted by the symbol beta. We told interference pattern consists of alternate bright and dark fringes. Whenever we have an interference pattern, it is alternate bright and dark bands, alternate bright and dark fringes, the bright fringe, the dark fringe, the bright fringe, the dark fringe, and so on. Dear students, the distance between successive bright fringes or successive dark fringes is what we call as fringe width. So very clearly I have mentioned here the meaning of fringe width. It is the distance between two successive bright fringes or two successive dark fringes, and that is what is called fringe width. Again, to analyze what is fringe width, it is the distance between two successive bright fringes or two successive dark fringes. Now let us go to the considerations. We told To get interference pattern, there has to be two coherent sources. So here, A and B are the two coherent sources which is separated by a distance small d. A and B coherent sources, they emit light waves of same frequency, same wavelength and constant phase difference, and the two coherent sources are separated by a distance d. This is the screen on which the interference pattern is observed. Screen on which the bright and dark fringes are observed. And the source and the screen are separated by a distance capital D. So small d, distance between the two sources. Capital D, distance between the source and the screen. Now, O is a point at the center of the screen and P is a point at a distance x from the center. So if you observe the diagram, O is a point which is at the center of the screen and P is a point which is at a distance x from the center. So these are the considerations. Two coherent sources, they are separated by a distance small d. The source and the screen separated by a distance capital D. O, center of the screen. X, distance between the point P and the center. Now, the path difference between the light waves from A and B reaching the point P is given by delta equals BP minus AP. What I mean to say here is the path difference. See, from A, one light wave, this is the first wave which reaches the point P. From the source B, this is the second wave which is reaching the point P. They are source. They emit light waves under given criterions. From A, there is one light wave reaching the point P. B, another light wave reaching the point P. So the path difference between them, delta, should be BP, the path BP minus AP. So this is the path difference between the light waves. Now, in order to calculate this path difference, what is the path difference? BP minus AP. So I need to calculate BP and AP. So, if I need to calculate BP, I will consider the triangle BPR. Right angle triangle BPR. Apply Pythagoras theorem, calculate BP. So I have BP square equals BR square plus RP square. BR square plus RP square. This BR square plus RP square. Therefore, I write that as BP square equals D square plus, now what is RP square or what is RP? This RP is nothing but PO plus OR. PO plus OR. PO plus OR is RP. What is PO, students? X. What is RO? This is D by 2. So X plus D by 2. So I have X plus D by 2 whole square. Or using the identity A plus B whole square, D square plus X square plus D square by 4 plus 2xD by 2. 2 and 2 gets cancelled. This is what is BP square. So we have calculated BP square from the triangle BPR. Similarly, from triangle APQ, AP square is AQ square plus QP square. You have to observe the diagram. And this is now X minus D by 2 whole square. And when you simplify, AP square equals D square plus X square plus D square by 4 minus XD. Now just look at this. BP square minus AP square. D square, X square, D square by 4 gets cancelled. Again D square, X square, D square by 4 gets cancelled. So what remains here? 2XD. So BP plus AP into BP minus AP is 2XD. How did I get that? A square minus B square. So BP minus AP will be 2XD divided by BP plus AP. Rearrange this. Now, if P is very close to P, we get the path difference as XD divided by D. So, path difference between the two waves reaching the point P is X into D divided by capital D. Now, first we will consider a bright fringe at P. So, the first condition is I will consider a bright fringe formed at this point P. And what was the condition for path difference? constructive interference, bright fringe, it is n lambda. Nene madudwala, constructive interference, formation of bright fringe, that is n lambda. So this path difference here, what we calculate, xd divided by capital D equals n lambda. So this x is n lambda d divided by d. Now for nth bright fringe, xn is n lambda d by d. N plus 1th bright fringe, xn plus 1 n lambda d by d. So when we simplify, the fringe width turns out to be very important expression, lambda capital D divided by small d. Beta fringe width is equal to lambda capital D divided by small d. Now what is lambda? It is wavelength of light used. So fringe width is directly proportional to the wavelength of light used. Capital D, distance between the source and the screen. So fringe width directly proportional to the distance between source and the screen. Small d is the distance between the two sources. And therefore we say the same expression also holds good for a dark fringe. Now, to note here, at the center of the screen, always bright fringe is formed. At the center of the screen, wherever you have an interference pattern, always a bright fringe is formed. What is the reason? The reason is the waves reaching that point, the central point on the screen, have constant phase difference. The two light waves which reach the central point on the screen, the center of the screen, always have constant phase difference. Therefore, the central point is always bright. Now, how do we get the two coherent sources? One is called division of wavefront. The other one is called division of amplitude. Divide the wavefronts into two halves. Amplitude of the waves into two halves. That is where we get the coherent sources. So, what are the conditions for interference, students? The two superposing light waves, the two waves which superpose each other, should have same frequency and same wavelength. Same frequency and same wavelength. Amplitude of the superposing light should be nearly equal. The amplitudes, peak values, maximum displacements of the two superposing light waves should be nearly equal. There should be constant phase difference, and the two coherent sources should be placed very close to each other. So you see, they should have the same frequency and same wavelength, the two waves which superpose each other. The amplitude of the two light waves should be the same. The superposing light waves should be of constant phase difference, and the two coherent sources should be placed very close to each other. So in my session today, students, very importantly, we have derived an expression for fringe width, and we have understood the conditions for interference of light. Next, I will be discussing diffraction of light. Until then, have a nice time. Thank you.